Thank you very much. Good morning. Welcome back to day 2 of our main conference here. Did you all enjoy the party last night? Yes. I feel I should ask that again because that was slightly lackluster. Did you all enjoy the party last night? Of course you did. Of course you did. Good. Now, you've seen Corey going around photographing. We might even make room for another selfie later in this keynote presentation. People have been asking when those photos will be available. They'll be up on Flickr around about a week's time. So you can look for your photos of yourself with Showgirls, with Elvis, with the Rat Pack, with all of those people. They'll be around. Also, you remember yesterday I was telling you what happens in Vegas will have to be justified on the expense report. It turns out also that what happens in Vegas for AstriCon is being videoed and will be made available for other people to watch on the AstriCon website, probably in about 3 weeks' time. So if you're in that position, and I know a lot of people have been in the position of really wanting to go to about 3 talks that are all on at the same time, and that's partly, in fact, it's exclusively because we've got such great content this year. If you're in that position, then those talks will be available in about 3 weeks' time, and you'll be able to go and find those. So that's great. Now, I wanted to say thank you very much to the TMC people. If you've seen the people behind the registration booth, those are the TMC people. In particular, you've probably seen little Tash wandering around. And the TMC people are people that organise the logistics for us and make sure the event flows very smoothly. And they do that in concert with one person in particular in Digium, and that is Julie Webb. So I'd just like you to join me and just say thank you to TMC, Tash, and Julie Webb for a moment, please. So you remember yesterday I was mentioning the fastest dude to the dial tone. Well, it turned out we had a bit of a rush. Whereas take-up had been just a bit slack on the Wednesday, or yesterday, Melissa and I were having to beat people off with a stick. Lots of people came along, and we did get some eventual winners. So I'd just like to invite Melissa, who's Digium's training manager, to come up and to announce the winners. And Alison, if you could make your way to the stage as well for the obligatory Alison photo opportunity, that would be appreciated. Thank you.
Excellent. Good morning. All right. Some winners. I think we'll announce number 3 first. I happen to know that he's in the decap room testing right now, though. Okay, he doesn't have a decap in yet. He came in 3rd. Good. And that would be Jose Franco.
Jose Franco, what was his time, Melissa? The time?
Well, he completed the task in 4 minutes and 30 seconds.
4 minutes, 30 seconds.
Okay. The second winner is an old pro. In fact, he's one of the only double decaps we have, and that is Tony Russell.
Tony Russell. Excuse me, Melissa. And Tony Russell wins the iPad Mini. Does he not? No.
4 minutes, 5 seconds. Now, the winner is no surprise to anyone who has seen him keyboard at all. Coming in at 3 minutes and 14 seconds for the task is John Keniston.
Great. Thank you very much, Melissa. And Melissa and Justin did a fine job in organising the fastest dude to the dial tone. By the way, if you're unaware where that title came from, it's literally because the very first contest was to get to a dial tone on an analogue phone. We put a Digium card inside a PC. Asterisk source files were there but not compiled, and the task was to compile them and actually get a dial tone onto an analogue phone. So that's how the fastest dude to the dial tone came about. So Asterisk 12 has been out for a while, and you might have seen the release that Asterisk 13 is now available as well. And what we've noticed is that this project, one that I got involved in 8 years ago that I thought was really vibrant and relevant right then, is even more relevant, even more vibrant than it's ever been. And the fact that Danny asked in this audience how many people were new yesterday, and about half put their hands up, is really, really exciting. And of course, none of it would be happening if it weren't for one man in particular, the guy that started it all. Please welcome Mark Spencer.
How's it going out there? You guys enjoying the show? So again, I want to give another thank you to Julie for organizing that party. That was just really an awesome party last night. How many of you guys went to the party? All right, good. Glad to see that. So, Asterisk, I guess, has been a pretty long project for me. And in the early days, I tended to hire a lot of really young people because they were really cheap and they had a lot of energy. And in fact, there was one year at Digium where we had about 50 people in the company, and 5 of them were graduating. Of those 5, 3 were graduating high school. So there was another telecom company in Huntsville that had a great co-op program, still have a really good co-op program there. And so a lot of times those co-ops would come and visit Digium. And there was one of those co-ops that came and visited Digium and just really kind of got excited about this Asterisk thing. And so in addition to doing all his duties at the other company, he would come and work on writing Asterisk software, learn how to install it. He was one of those people that gets really excited when you can hear dial tone coming out of your computer. I mean, it's hard to find an audience other than here that really can appreciate that. So, but anyway, so he would work on Asterisk and then go do his day job. And but I think everybody kind of knew that he really had this passion for Asterisk. And so one day at his other job, they kind of pulled him aside and they sat him down. And somebody from HR came out and they said, "We need to have a talk with you because you are addicted to Asterisk." And when you're addicted to something, you've just got to quit cold turkey and let it go. You've got a real issue, real problem being addicted to Asterisk. And so then he came and told me about this, and I thought, well, that's pretty serious. I think I've got a different plan though. I mean, I think if you're addicted to Asterisk, at Digium, we would love to just kind of continue feeding you that drug and getting you even more involved with it. And so, in fact, he did come and work at Digium and worked as a software developer and eventually came to lead the whole Asterisk project before moving on to Red Hat to lead even more open source projects. So I would like to welcome him back to AstriCon. This is none other than our own Russell Bryant, a recovering astroholic, but not yet totally recovered.
All right, thanks a lot, Mark. That was great. And it's totally an honor to be here. I appreciate the invitation, and I've been having a blast. It's great to be back. I've actually, like Mark said, I've been involved in Asterisk for quite a bit of time. I've only missed 2 AstriCons. I was even at the first one. I dug up an old picture even for the first one in 2004. We haven't aged a bit. That's Mark and Allison and myself from 10 years ago. But yeah, the truth is, I do love Asterisk. I loved Asterisk then, and I absolutely love Asterisk now. I'm proud of the role I've played in the history of the project. And since passing the torch of the project leadership on, I've become even more proud of the way that the project has been going. I mean, if you've watched what Asterisk has been doing in the last few years, they're doing amazing work. I mean, from totally reworking some internal implementation details that really needed work, things that we dreamed about and felt like we couldn't even figure out how to do it, but these guys have pulled it off. A new SIP channel driver, another huge thing for Asterisk that we kind of like, man, one of these days we got to do that, and not even sure how we would go about doing it. They've pulled it off. Chan PJ SIP is a huge addition. And the thing that I'm probably most excited about, and I think is most critical for Asterisk's role in the future of communications, is the new emphasis on new APIs, new and better APIs for Asterisk. So if you haven't taken a look at ARI, then absolutely take a look at it and go watch some videos of some of the presentations this week about it. I think that's huge. So congratulations to those that are working on the project. I think you're doing an amazing job, and thank you for all your hard work. So what I want to talk about today, if there's one thing that I'd like you to take away from my presentation, it's this point here. It's that the future of communications runs on the future of computing infrastructure. And when I say that out loud, it almost sounds obvious. But what I want you to think about is, I mean, obviously you care about the future of communications. You're here at AstriCon. Then if you care about that, then you should also be paying attention to what's happening at the infrastructure layer, the thing that all your applications are running on, because there's some really cool things happening there. And if you learn about it and you figure out how to make your applications make best use of that, then you'll be on an even better path to the future of communication. So I want to talk through this from a few different points today. And the first one is that I believe cloud is the future of both public and private computing infrastructure. So first of all, I say future, but depending on your use case, it's actually the present, like especially with web applications. The way that people have been deploying web applications on public clouds, like that's the way things work. Like web startups are all on a public cloud these days. But more and more computing workloads are moving to this type of infrastructure. Another key thing that in this point is I said public and private computing infrastructure. I think when people think about cloud, they assume that we're talking about public cloud. And yeah, that's where it started, right? Amazon has started this movement, but it's more than that. It's also this way of managing your infrastructure is now moving into private data centers on your own hardware as well. So cloud, what does cloud mean beyond like a marketing buzz term that is often used in a way that's meaningless, right? No, but I actually think there's some real stuff happening here. And if we talk about cloud at the infrastructure layer, and I'm talking about your compute, your network, and your storage resources, there are some new stuff. And if I were to put it in a sentence, I would say it's a self-service, on-demand, shared pool of compute, network, and storage. And that sounds kind of nice, but you're like, Russell, look, I've been using virtualization for a while. What's new about here? You're just putting a new spin on it. And I think there is some new stuff, and don't miss it. And if I were to boil this down to the most concise description of what's new about cloud infrastructure versus your traditional virtualization management, I would say it's this. I would say that with virtualization, you got consolidation. So you started with physical boxes, and you're running applications on each of them. The problem is you're not fully utilizing all of your hardware. So along comes virtualization. You can consolidate these workloads on fewer hosts, save yourself some money on buying less hardware, less power, all that good stuff. So that was great. But the way you manage that stuff was not a whole lot different than you managed your bare metal. So with cloud, it's taking that infrastructure and making it a lot more agile. So cloud is about agility. It's being able to build and react much faster than you could before. So now let's talk about what agility means in infrastructure. So agile infrastructure. First key point I would say is that it's self-service. So when I want a machine to do something, when I want a virtual machine, I shouldn't have to put in a ticket with my IT department to go to create a virtual machine for me. And then on their end, maybe they got to go put a ticket for the storage team to go to create a storage volume for me. And then they got to put in a request to the network team to allocate an IP address for me. And then maybe weeks later, I've forgotten why I even wanted the thing in the first place. I guess it's too slow. I need to be able to go in there and do it myself. And second, on demand, right? When I go in and do that for myself, I want it now. I have an idea, I'm in the zone, and I need that infrastructure spun up in minutes, not hours, not days, not weeks or months, as people may have had to do before. And so self-service and on demand. And there's different ways you can present that. And one way would be maybe it's a web portal that you go to, and that's great. Provide you some, but what's even more revolutionary about cloud infrastructure is they put an API on it. Okay, so not only can I get this stuff myself and on demand, but I can write software to do it. So now, so if I can write software to create servers and destroy them and change my network topology and all this stuff, using logic built into software, then what new things can you do? And that allows things like automatically scaling. Okay, so we talk about scaling. You scale it involves multiple servers. But what if you'd have software looking at the load on your deployment and automatically expanding your infrastructure based on that load? That's powerful. So all that's cool, from a technical perspective. But what about the business side? With that agility, all of a sudden your teams are a lot more efficient. You can move a lot faster, build things out quicker. That's great. There's also a key money side to this too. Instead of having to make a huge upfront investment in your infrastructure, you're paying for it as you go. So if you go look at, say, the way public clouds charge for their infrastructure, for servers, you get to pay by the minute, and you're not paying. You're not having to buy a server up front. You're not paying by the month, by the hour. For a lot of use cases, even by the hour is not flexible enough. There's a lot of cool things people do with this API-driven infrastructure that's rapidly creating and destroying machines. And and being able to pay for only what you use is critical. And so like another way that I would put this in a concise statement is that you get to pay for your consumption and you're not paying for capacity. And I think that's key. So like if you think about the auto scaling case, you shouldn't have to pay for like what your peak capacity is all the time. You should only have to pay for that amount of capacity for that one day where your app got featured on like a big news outlet or something. And so that's a key part of what cloud infrastructure has brought. So who's using this stuff? So I mentioned before that I say it's the future, but really it's the present for a lot of cases, and especially the web. So if you really get into WebRTC, then you really need to jump on this. This is the way that web apps work. But more and more workloads are moving to this stuff, and part of that is being driven by it's not only public cloud anymore. You can deploy this type of infrastructure in your own data center, and so that's happening. That's something that we're seeing now is it's being deployed in enterprise data centers all over the world. And what's really cool to me and something that I've been working on in the last 6 to 12 months is even telcos are looking at using this type of infrastructure as like a next generation approach to managing their network services. So let's talk about what's happening to telcos in a little bit more detail. So there's this effort called NFV, and it stands for Network Function Virtualization. And this is a pretty major thing for the telcos. So typically, network functions, when I say network functions, I'm talking about things like firewalls, NAT boxes, CDN boxes, intrusion detection systems. Some people refer to these things as like the middle boxes. These things are traditionally things that are baked into hardware, right? And they're expensive, they're not flexible. But what the telcos are saying is that's not good enough anymore. We want to pull the software out of this hardware, and we want it running on cloud infrastructure. We want these things as cloud images that we can deploy on your standard commodity hardware. And this is all being driven by pressure, right? So they have pressure to deliver new services faster and cheaper. So the way this has been going down, it's been happening quite fast, especially for such a giant industry. Just a couple of years ago, they put out a white paper, and this was put out by the NFV working group of the ETSI standards group. And this white paper presented this idea. They're saying our next generation data centers providing network services it's going to be based on this flexible infrastructure, and our network functions are going to be virtualized running on top of that. Now, they didn't know exactly how they were going to pull this off, but they knew that's the direction they wanted to go. In the last couple of years, the industry has been mobilizing pretty aggressively to figure out how to make this happen and try to figure out like what software is already out there, what things can we put together to accommodate these use cases. So just within the last couple of months, this stuff is happening right now. The Linux Foundation launched a new effort. It's called OPNFV, and it stands for Open Platform for NFV. And it's bringing all these people together to figure out how to build an open reference platform for this. So it's like what are the open source projects that we can put together to accommodate this, and what gaps are there? So what things are all these projects missing to make that happen? And once they identify that, I'm going to go contribute to the projects and add those features. Meanwhile, the telcos and the network equipment providers are doing proof of concepts, right? They're doing the same sort of thing. They're trying to figure out what they can pull together that exists and trying to give this a spin. And it's going pretty well. The timeline's aggressive, but it looks like that we're going to start seeing production deployments of this stuff in 2015. And it's going to be rolling out more aggressively as years go forward. So what does the architecture look like? This diagram is kind of noisy, but it's sort of this de facto NFV architecture diagram. This originally came from the NFV white paper. But I want to point out a few things that I want you to grab from the diagram. The first is in the bottom part where the color is darker. That's the infrastructure layer that they say they want. And that's what the Linux Foundation effort called OPNFV is working on. And what they're saying is they want commodity hardware for compute, storage, and networking. They want to use virtualization with that. And then they want like a cloud infrastructure manager to manage across all of that. And that's going to be the base for everything. And then on top of that is where they're going to run their network services. And I threw an Asterisk logo on there because I also want to point out how Asterisk fits into this architecture. That block says VNF, and VNF stands for Virtual Network Function. And using Asterisk as a virtual network function almost doesn't sound new. This is really natural for Asterisk. What you do is you're building a cloud image that's like a Linux distribution, an Asterisk, and maybe you do some config management integration, and maybe you put a nice API on it so you can manage it, which, well, isn't it convenient that the Asterisk project has been building a really awesome new API, right? Asterisk fits perfect in this model. And so, that's but this is a whole lot harder for some of these network equipment providers that are having to figure out how to deliver what they have traditionally provided in hardware appliances, with very custom embedded software in this model. But for Asterisk, man, this is easy, right? So there's a big opportunity there. And I also want to talk about what the software stack looks like. And that's up there on the left. And there's a lot of cool stuff happening in all these projects. So Linux, of course, is the base operating system. KVM is the hypervisor. Libvirt is an API for managing the KVM hypervisor, so that runs on each hypervisor node. Software-defined networking is another really big area of innovation happening right now, and there's a couple of projects a part of the stack for software-defined networking. One is Open vSwitch, and the other is Open Daylight, which is a software-defined networking controller to manage all the virtual switches along a distributed deployment. And of course, at the top of all that is OpenStack. So OpenStack is this project that manages, that presents an API for the infrastructure and then manages all the infrastructure underneath. So speaking of all these components, these open source components, that brings me to my second point for today. That's openness still matters. Okay, in this new world, openness still matters. So I have a question for you. How has openness impacted the success of Asterisk and other communications platforms? Right, let's think about that. Where would Asterisk be if it wasn't an open project, an open community? I think openness has been pretty critical to Asterisk. But what does openness mean? I think there's different ways to look at it. First is open source. Okay, so open source is like the first obvious one. But there's more. So just opening your code is not enough. It's community, right? And I believe everyone here believes in that. That's why you're here at this conference. You're here to meet with a group of people and figure out how to solve problems. And these open communities built around open source are driving the biggest technology trends we're seeing today. Part of that's cloud, and of course we've seen that in Asterisk. But when these communities come together, there's values that kind of naturally come out of that. And one of them is interoperability. I think this is an important one when it comes to cloud. So, with the way public cloud has started out, I mean, they're proprietary clouds, right? So, what would it take if you're heavily invested in one public cloud to quickly spin up all of your infrastructure somewhere else on another provider, right? If this is API-driven infrastructure, if you have software that can create all of your machines and all the storage and all the network topology that you need, at the push of a button, shouldn't you be able to, at that push of a button, go do it on another cloud? Absolutely. But that's not the reality today, and we need to value openness to make this happen, which brings me to open cloud. So open cloud is what it's been my big focus for the last few years, and this is the story of open cloud, right? And this is the story of Asterisk. I think Asterisk went through this path and absolutely won, and is still winning. It was the story of Linux, and it's the story of open cloud, and we're living through this right now. So I work on this project called OpenStack, and here's our mission statement: to produce the ubiquitous open source cloud computing platform that will meet the needs of public and private clouds, regardless of size, by being simple to implement and massively scalable. It's pretty ambitious, right? So we're gonna build some open source to do all of this. So let's look at some different components. So it's certainly open source. We're a very open community. Meet the needs of public and private clouds? Absolutely. It's being used in both capacities. Regardless of size and massively scalable? Yeah, we've actually done pretty well. I mean, there's room for improvement, but I mean, the deployments that are already out there today, hundreds of physical hosts, thousands, even tens of thousands of physical hosts are being managed by OpenStack deployments today. And the last part, which I would say we're doing the least well at, to be honest with ourselves, is being simple to implement. So it turns out, to build an incredibly flexible, massively scalable distributed system, it's kind of complicated, right? Like, who knew, right? So making that really simple to deploy and manage, we're still kind of figuring that out. I mean, people have figured it out, but these are companies that are really smart and have a lot of really good expertise that have figured out how to make this stuff work. I wouldn't call it simple. That's not where we are today. But again, it's honestly not a very old project either, and we're working hard and working fast. So a quick view of the history of the project. So it only launched in 2010, and it was launched by NASA and Rackspace. And at the beginning, Rackspace led the project there for a couple years, and then it was turned to a foundation. The OpenStack Foundation was created in 2012, and has been going strong ever since. And it's sponsored by a bit over 100 companies. There's a platinum tier of sponsors that's capped at 8 sponsors. There's a gold tier, where there's 17 of them when I checked the other day, and there's over 75 sponsors at the corporate level. So who are these companies that are sponsoring the OpenStack Foundation? I can't put them all on a slide, but I can give you a sample. So that's all of the platinum sponsors, and then a subset of the ones from the other tiers. And I find this list pretty impressive, and it's actually a pretty cool mix, right? All these companies are coming at this and have reasons for wanting OpenStack to succeed for very different reasons. In some cases, they're actual telcos. In some cases, they're major technology vendors. In other cases, they're like major web companies that need huge scale-out infrastructure management, service providers, and just lots of different, coming at this from lots of different angles. So okay, we have like a cool list of big company names, whoop-de-doo, show me the code, how many people are actually working on the project. And I really geek out about development community stats. And I like looking at this for Asterisk, and I look at this a lot for OpenStack as well. So the way we develop OpenStack is in a 6-month release cycle. And we just did our last release last week. It's called Juno. Over 1,500 individual people contributed code in that 6-month cycle. And those individuals are employed by over 125 companies. There were over 20,000 commits that were merged in that time frame. And the way we do development is every single commit, every single patch goes through a code review system. And on that code review system, there were over 120,000 code reviews done by individuals in that time frame. Now, also talking about our development process, the reason we can move this fast, this makes us one of the biggest open source projects there are, near the top. The reason we can move this fast is we value continuous integration and testing absolute requirement. That everything has to go through extreme testing. So when you post a patch to the code review system, it automatically kicks off a series of test jobs, runs a whole bunch of tests, the results get posted back to the code review system, and you can use those results as input into your code review. And also, after it passes code review and the patch has been approved, then it has to go through all this testing again against the current state of all the repositories. And if it passes all of those tests, then the patch gets automatically merged. So, because the way we do that testing, it was actually, in that 6-month time frame, there were 1.8 million test jobs. And a test job means it's creating a virtual machine on a public cloud, installing OpenStack, and running a ton of tests on it. 1.8 million times. And for the one that's 1.8 million times, that means we created 1.8 million virtual machines on OpenStack-based public clouds. We're really dogfooding this stuff to make it happen. And for testing this heavily, we also generate a ton of log data, and so we've also built a lot of cool infrastructure around analyzing the log data. So, when you do this amount of testing, and your failures are not always so straightforward. Sometimes, in the Asterisk project, has seen this stuff too, in their project testing, is tests aren't always so friendly to fail all of the time. They fail some of the time, and that gets frustrating. And so what we've done is we have this system using Logstash and Elasticsearch. Those are cool projects you can go check out. But we can classify a failure and do a search for this pattern that we see in logs when an error occurs, and see how many times it's happened in the last 2 weeks across all the test jobs, and look for patterns and try to help us figure out what's going on. So we take testing very seriously, and that's how we maintain quality while we move this fast. So if I've piqued your interest about OpenStack at all, give it a try. There's a couple easy ways to do it. First, you can use an OpenStack distribution. One of them is a community distribution. It's called RDO. You can go to openstack.redhat.com. This runs on either Red Hat Enterprise Linux or any of its derivatives like CentOS. And you can try it out on a single host or even just within a single small VM on your laptop and give it a shot. And of course, you can use one of the public clouds. And on the OpenStack website, there's a marketplace and lists some public clouds. And you can go over there and hit their APIs. So that's OpenStack. So brings me to my third point for today. So if cloud's the future, and open cloud in particular, and if you're building the future of communications, and that's going to rely on cloud infrastructure, then you should look at how can you improve the applications you're developing to take advantage of cloud. So I want to kind of talk through some ways that you could think about taking advantage of cloud to improve your application. So let's talk about scaling. Horizontal scaling is the way, you have to think about things in terms of horizontal scaling. Now, don't get me wrong, performance of a single server, that's interesting stuff. Don't forget about it. We need to make sure that's solid, but the way you scale out is horizontally, and that means multiple servers. And with Asterisk, that means Asterisk is a component of the application. You're going to have several Asterisk app servers, which, to do that, you start thinking about the way you do it, you might need a really good API. Man, gosh, the Asterisk project's on top of it, right? I mean, Asterisk fits in perfectly with this model. And not just scaling horizontally, but look at scaling horizontally automatically. Don't think of your application as 3 servers. Think of it as just in servers based on your load, and being able to expand and contract based on what's coming in. And in OpenStack, we have a project called Heat. If you're familiar with the CloudFormations API of Amazon, Heat started as an open source implementation of that API, but now there's an OpenStack API and more features included. One of the things that lets you do is define your application or define your deployment in terms of several virtual machines, and they could, one of them could be a SIP proxy that you're using as a load balancer, and then you could have several Asterisk servers behind that. And you can define these auto-scaling rules, have it automatically watching the load of your Asterisk app servers, and then automatically creating new ones when the load gets too high, and automatically updating the load balancer configuration as a part of it. So you just set the stuff off and running. Like, cloud infrastructure can do this for you. And finally, design for failure. One of the benefits of scaling horizontally is you're not putting all your eggs in one basket, right? There's actually a benefit in not making the single server bigger and bigger. You want to minimize what you lose when one server goes down. You got to design, like, your VM's gonna fail, okay? They are, whether that's software problem or the underlying hardware. But if you design your application such that if you lose one of them, you're not losing the whole application. The application overall still works. Maybe you lost some calls, but at least you didn't lose everything. You didn't lose all of your calls, and certainly the application is still available. You got to design that way. That's what future applications are going to look like. Another way to look at cloud infrastructure is you got to be aware of your CPU and memory performance, and especially because you're not the one who set up the bare metal hardware. You may not be as clear of what you're getting. So you should pay attention to what you're getting, because it's not all the same. And the first point, beware of overcommit. So to drive costs down, a common thing that's done is to overcommit resources. So that means the physical hypervisor may have, say, 8 CPUs in it. The virtual machines that get put there, maybe you allow 24 virtual CPUs, and that's okay if the VMs, on average, are not all using all of their CPU power, right? And that's great. You get to pack more into a single server, but that also means that if you're unlucky and then your VM is co-located with some other ones that are like pegging the CPU all the time, then your performance is not going to be consistent. It's not going to be deterministic, and you're going to have no way to predict when that's going to happen. Your performance may be great today, and tomorrow it may be crap, right? And you have no way to see that happening. That's a problem. Maybe you don't notice as much if you're just serving up web pages. If you're doing real-time communications, you're going to see it, and it's going to be a big problem. So you got to pay close attention to this. So if you're using a public cloud, figure out what they're giving you. They may have different instance types or different flavors, is what we call them in OpenStack, that they provide you different performance guarantees. And you need to make sure that you use the right one for the requirements of your application. So in the OpenStack space, we're doing a lot of development in support of the telco NFE use cases, because their requirements are basically the opposite of overcommit. They need the best performance and absolutely deterministic. So one of those things is NUMA awareness. So NUMA stands for non-uniform memory access. And what that means is in monitored servers, you've got multiple CPUs and a bunch of memory. All the CPUs do not have the same amount of bandwidth to all of the memory. There's memory local to each CPU. So when the infrastructure management goes to place virtual machines on these hypervisors, we have to be careful and say, for these virtual CPUs and memory, we need to sort of put it in a subset of the host to make sure that we don't get bad performance from not using the local memory. And there's another step further. So, instead of overcommitting CPUs, some applications require a dedicated one. So for every virtual CPU, I need one of the physical CPUs dedicated to that to get the best performance and the most deterministic performance. So that's something we've been working on adding. Another one is dedicated memory. So you can reserve large pages of memory on a host, and then we can expose those directly to a virtual machine. And that improves memory performance as the virtual machine in its memory access hits a lot fewer TLB cache misses. Now, these technology items, they're interesting just from a virtualization perspective, but there's another layer of interesting work that we've had to do just at the cloud infrastructure layer. Because when you're using cloud infrastructure, you're not saying, I'm creating a VM, it's going to go on this specific host, and I want to pin this CPU to that one. Like, you don't have that level of visibility. That's part of the value that the cloud infrastructure management brings you, is you don't have to care about the hardware behind it. You're just saying that my application requires this many CPUs and this much memory, and then we've had to add the ability to say, it requires dedicated CPUs. That's all you have to say. And then on the back end, it figures out the best way to accomplish that. And so that's some of the work we've been doing around that in OpenStack. So that's CPU and memory. Now there's also a lot of work around network performance. This is important for communications applications. And the telcos have been very clear with us about that for their deployments. Typically with virtualization, you use these para-virtualized network devices, and it's great for a lot of reasons, but you don't necessarily get quite as good as performance as you would on bare metal. So we've had to do some things to get bare metal level network performance using cloud infrastructure. One of those is support for SR-IOV network devices. And so what that means, so think of taking like a physical network device and exposing like the PCI device directly up to the virtual machine. But in reality, you don't have that many NICs in the box to expose a physical NIC to every single virtual machine. There may be like 80 of them running on the host or something, right? So what the network devices do is they present the network device to the host as a series of, they call them virtual functions. So there's like all these virtual PCI addresses, even though in reality they're all pointing at the same physical NIC. There's several virtual PCI addresses, and then we can expose those up to the virtual machine. So now we have support for that, and that gets you much better performance. There's another cool thing that you can go dig into. It's called Intel DPDK. DPDK stands for Data Plane Development Kit. And this is for like absolute like peak performance packet processing. And effectively what it does, as far as best I understand it, it's taking the hardware, like mapping it in user space, and letting you do your optimized packet processing in some user space code. It's just like, well, forget the kernel networking stack. We're just going to bypass the whole thing and do it directly in some code. And it gets some huge performance benefits depending on your use case. So we're looking at enablement of that as well. And the last thing I wanted to talk about on making your apps cloud aware is storage. Okay, so when you move your apps to a cloud infrastructure, you have some new storage options. And so let's talk about some storage options. Let's pick an example of an application that everyone's familiar with. Let's say voicemail. Okay, so Asterisk has had app voicemail for a long time, and the default way that voicemails are stored is on the local file system. So when you create a server on OpenStack or cloud infrastructure, you get local storage. You can use it just like you would on any other server. And then when you destroy that virtual machine, the data and the storage associated with that all gets thrown away. But when the storage is there available, you can use it just like you normally would. There's also a project called Cinder, which provides block storage as a service. So it's a storage API. And what you do with that is you can go to that API and say, create a 100 gigabyte storage volume for me. You could create that based on like a virtual machine disk image, and you could boot from it. And then so when you destroy that virtual machine, all the data is still there. Or you can just create this as general storage and attach it to running virtual machines. So you can have applications running, and then maybe you need more storage, so you go to this API and create some storage volumes, and then call another API to attach them to the virtual machine. All good stuff. And effectively, like in the voicemail example, it's really no different. It's just that you can get more storage on demand by hitting an API. One of the things, we actually did this quite a long time ago as well in app voicemails. We added support for storing voicemail in a database. And that's cool. So that allows you to start, it gives you a handy way to scale voicemail out on multiple servers, pointing multiple servers at the same database. So the way you would typically do this is, you create a database server and you manage your database. But when you go to cloud infrastructure, sometimes there's a way to make this a whole lot easier. And in OpenStack, we have a project called Trove that is relational database as a service. So instead of having to manage a MySQL database, you hit an API that says, give me a database. And on the back end, it gets magically created, and you don't have to manage it. You don't have to worry about the backups because it's being done for you automatically. It just makes it a whole lot easier. Now, the most cloudy of storage options that I want to point out, which I think is actually like a perfect fit for voicemail, actually, is object storage. And in OpenStack, we provide that as a project called Swift. If you're familiar with Amazon services, this is analogous to Amazon's S3. So the API is actually fairly simple. You have blobs of data, and you push it to the API to store it for you, and then you can use the API to get that data back later. You can organize the data as containers, and then you put these objects in the containers. And these objects could be, say, voicemail recordings. But what's cool is that on the back end, this stuff is designed to be like massively scalable, okay? Like, geographically replicated around the world, just many petabytes of storage, like scale. Like if you use this as your way to store some stuff, like it's not going to be your scale limit. Your scale limits are going to be elsewhere. And so that's a really good example of making something cloud aware. And not having to worry about local storage. And also a good example of like taking state and pulling it out of like individual VMs. So if you lost a VM, you're not losing like any recording stuff that was stored locally there. So take a look at object storage and figure out how you can apply that to your application. Okay, so let's recap. I told you at the beginning that if there was one thing I wanted you to get out of my talk today, it was this. It's that the future of communications runs on the future of computing infrastructure. And so again, if you care about the future of communications, then you should, and building those apps, then you should pay close attention to what's happening at the infrastructure layer and figure out how you can take best advantage of that. Went through a few points. I said that cloud is the future, or maybe even the present, of both public and private computing infrastructure. I said openness still matters. So open cloud matters, and it's coming, and it's real. And finally, as you build the next generations of communications apps, figure out how to make it cloud aware so you can make best use of this infrastructure. I mean, that's why we're building it in the first place, to make your apps more flexible, more scalable, and make your life a lot easier. With that, I'd say thank you very much. It's an honor to speak to you today. So thank you very much.
Thank you so much, Russell. Thanks a lot. Quick announcement. If you are a DCAP, that's a Digium Certified Asterisk Professional. You've probably seen these people wandering around with the little blue ribbons under their passes. If you are, and you've not yet got your special DCAP gift that we were giving away at the DCAP reception, I'm not going to reveal what's in the box, but it's very exciting. If you've not got that yet, see Melissa. She was up on stage just a minute or two ago. See Melissa, and she will have that for you. Now, feedback is incredibly important, and we welcome both very positive feedback, but we also welcome developmental feedback as well. Or if you've got feedback about where you think AstriCon should be next year, we welcome that too. All you've got to do is go and talk to the TMC folk at the registration booth, or if you know you're talking to a Digium person, you can tell them as well. We welcome that, and we've had some very important feedback about the selfie that I did yesterday. The important feedback was that it didn't get the whole audience. It only got one half of the audience. So we're just going to recreate that now with Corey's help to get a selfie that gets the whole audience, and he's going to take 2 shots and then stitch them together. Okay, so please look your most attractive at this point. Especially you, Mark.
So quiet.
It's real. Thank you very much. And thank you, Corey. Now, some of the really excellent feedback we've had, and believe me, people come up and tell me which sessions they're loving and which things they've been enjoying doing. One of the things that everybody who participated seemed to enjoy, and even the people that didn't participate and just watched it enjoyed, was the hackathon. And we still got the hackathon prize to give away. It's the popular choice prize. And so I'm going to invite Billy Chia, who masterminded this operation, up onto the stage to do just that. Come along, Billy.
So I was very excited. Today's award is the Popular Choice Award. And what's wonderful about doing a hackathon, a software competition, where under great time constraints, you have to try to come up with something, and at the end, you hope it works, is that when you give awards, you try to have some awards that are given away just for, we gave away, hey, the Asterisk team said this is the best use of Asterisk, or the Respoke team said this is the best use of Respoke, and we also gave away a Clarify award. We also invited some expert judges to come, and the judges judged and gave away first, second, third place yesterday. But this is my favorite award because this is the Popular Choice Award given by you, the Asterisk audience. So thank you to everyone who voted for the Popular Choice Award. I saw many teams were campaigning furiously on Twitter saying, vote for me. I saw people talking in the hallway saying, vote for me. And the final vote was very close. The winning team won by only 2 votes. If you can imagine that. So it was very close. The prize is a $100 Amazon gift card in addition to free admittance to next year's AstriCon. The winning team, their app used Asterisk, they used Respoke, they used Chan Respoke to connect them together, and they used the Asterisk ARI. All of this together, it is your favorite app was Monkey Business by Steve Davies and Tony Russell. Come on up, guys. Coincidentally, it was also the Respoke team's favorite app, and I believe they've worn Respoke shirts in honor of that. So.
Yes, do make sure you get the Alison photo opportunity. And by the way, if you want an Alison photo opportunity, don't be shy. She doesn't bite. You can go up and get that. And actually, I'd like to welcome, for the first time at an AstriCon, Mr. Allison, who's here, as a reminder. So, Pete, nice to see you. Okay, so that's just about it for this keynote. We've got an amazing collection of sessions for you today as well. And then we're all going to gather back here to see Matt and the team go through the Asterisk roadmap and tell us what's been going on and what's coming down the line. So thank you very much, and I hope you all have a great day.